Hello, am I audible?
Yes.
Sure. So, today is the first lecture for NEET crash course. Before starting the syllabus, let's discuss the strategy that we'll be following for the next 7 weeks. Yeah. So let's first start with the pattern of the examination. So in NEET, you will be getting 50 questions from physics. Out of these 50 questions, you have to attempt 45 questions. Basically, the question paper consists of two sections in physics. In the first section, you have 35 questions. These all 35 questions are compulsory. Then in section B, you have 15 questions. And these out of these 15 questions, you have to attempt 10 questions. So overall, you have to attempt 45 questions. The same way in the chemistry, 50 questions, 35 in section A, 15 in section B, and you have to attempt overall 45 questions. Biology is again divided into two sections, zoology and botany. 50 questions for zoology, 50 questions for botany. Out of 50, you have to attempt 45 in zoology and 45 in botany. So this is the pattern of the question paper. Now, the total marks, so you have total 180 questions. Each question will carry 4 marks. So it's around 720 marks. Huh? This is the total one. So if you want to crack JE and you want MBBS in government schools, then for general category, last year, the cutoff was around 600 to around some 609, 610. Means last year, some of our students got 610 and they are in government medical colleges. So around 610 was the cutoff. But if you have some sort of reservation or you have an RI quota, then this can go significantly down. And if even if you can't score 610, you are scoring something around 350, 400, 450, then still you have chances in private engineering colleges, medical colleges. And you can even apply for other courses like BDS, B Pharma, physiotherapy. There are plenty of courses which take admissions through this NEET test. So our strategy for the next 7 weeks would be out of these 45 questions in physics, chemistry, and biology, we have designed our course in a way that you will be able to attempt around 35 questions. So we'll cover almost full syllabus of class 12. We'll be covering 80, 70% of class 11 syllabus. You'll be able to attempt around 35 questions. So out of these 35 questions, if you can score 30 questions are correct in your exams, 30 are in chemistry, the similar pattern, if you can score 80, then you can get a good score in NEET. This will be the strategy. So this is bare minimum. If anyone of you is performing very well and you think, okay, you can do more topics, the topics which are mentioned in the schedule, if you can do more topics, then we can arrange one-to-one classes in the evening also. That totally depends upon your performance. So if you have anything discussed regarding the schedule or strategy, we can discuss right now. In the next thing, we'll discuss with the content, like the textbooks that you will be following. Aksha, Ellen, Hanifa, Memuna, you want to discuss something?
No, sir. Thank you.
Okay. So that was about the pattern of the exam. The next thing is, now, if you want to go to the reference books, see, for theory, the class notes, the class lectures are sufficient. So it's a very short duration crash course. You just have 7 weeks. So in 7 weeks, it won't be possible for you to read theory as well. So for theory, it's our responsibility in class. Whatever theory is required for NEET, we'll try to cover it in the class only. Your responsibility will be to solve numericals. And for numerical solving, you'll be using only 2 books. You'll be using NEET PYQ by Arihant If you have this book, well and good. If you don't have this book, we'll share this soft copy of this book with you. And then you have JPYQ. See, in NEET, what happens is they usually give questions from the previous year's question of NEET, or if there is some tough question, they are from previous years of JEE. So when I'm saying JPYQ, I'm telling about AIEEE plus 2019 to 2021 question of JEE. Means last 3 attempts. If you talk about the number of numericals, this will be around 40-50 numericals in a chapter, and this will be around 40 numericals in a chapter. So after the class, if you study for 3-4 hours for a subject, means in a day if you are doing physics and chemistry, else than the classes you are doing your self-study for 3-4 hours, then this target is doable. Like, it's not an unrealistic target. You can meet that target if after the class you practice your numericals for 3 hours. And as mentioned in the schedule, on each Friday you have a mock test. First mock test would be subjective because you want to know how you calculate things. And from the next Friday onwards, we'll be giving you the mock test based on exactly NEET pattern. So this schedule, basically, this NEET pattern, 50-50 and 50-50. So that's the schedule and strategy. So do any one of you have these books, JPYQ and NEET PYQ?
No, sir.
What about the rest? Ellen, Hanifa, Maimuna, do you have this book?
No, sir.
It's okay. So I'm asking someone from the operations team. They will share a soft copy of these books with you. So if you want, you can buy it, a hard copy from a bookstore. But if you soft copy will work for you, we are sharing a soft copy. Don't refer any other thing. You have very limited time, so don't go to the course material of Ellen or Akash or any other book. You don't have that much of time. You have very limited time, so the things that we'll read will be very, very specific. Okay, so we'll start with the first topic, which is vectors. So the first class, I will go a bit slow. I just want to know how much you people remember from the class 11. So Hanifa, what are vector quantities? Yes, Hanifa. What are vector quantities?
Sir, I don't remember.
Sorry?
I don't remember.
Okay, don't remember. No issues. Alan, do you remember what are vector quantities?
They have both scalar and magnitude.
Okay. Aksha, what are vectors exactly? Say, if you don't know, say don't know. I understand. You have read these things in class 11. 1 year is a very long gap. But at least I should know from where I have to start. Huh? Otherwise, I will assume that you know these topics. I won't start from the scratch. I want to start from the very scratch. Yes, Aksha.
Quantities with both magnitude and direction.
Magnitude, direction. Mamuna, what are vectors exactly?
They are like the quantities which have both magnitude and direction are defined distinctly.
See, so when we let's start with the concept of physical quantities. So when you talk about physical quantities means measurable quantities. All quantities that you can measure are physical quantities. You can divide these physical quantities into two categories. These physical quantities could be vectors, or these quantities could be scalar. Scalars are those quantities which have only magnitude, no direction. They don't have direction, they just have magnitude. And another important thing about scalar quantities is they follow algebraic laws. Means to add two scalars, you don't need any other law, any new law. You can just add them up algebraically. The examples of scalars are mass is a scalar, speed is a scalar, work is a scalar quantity, energy is a scalar quantity. All these examples are scalar quantities. So when you want to add two masses, you don't have to apply any law, vector law. You can add them up algebraically. So when you are subtracting two work done, you don't need any vector laws. You can subtract them or add them up algebraically. So for scalars, you don't need any special algebra. That's why you don't have any chapter by the name of scalar in physics. But when you talk about vectors, vectors are something special. Vectors are those quantities which have magnitude plus direction. So they have both magnitude as well as direction. And not just magnitude and direction, they follow vector laws also. They follow vector laws also. So if you have a quantity which have just magnitude, it doesn't have any direction, or if you have a quantity which have magnitude and direction, but it don't follow vector laws, then we don't call that quantity as vector. We consider that quantities as a scalar. Okay, do you remember any quantity which have magnitude and direction, but still we consider it as a scalar? This is an open question to all of you. You read that quantity in class 12th also. A quantity which have magnitude, which have direction, but does not follow vector laws. Jasola. Do you remember any such quantity?
No, sir.
Electric current. Electric current is one such quantity. Current have magnitude, current have direction, but still you don't add current vectorically. You use algebra for adding current. So current is a scalar quantity. So these are vectors, magnitude, direction, and they follow vector laws. Hanifa, give me some examples of vector quantities, one or two examples of vector quantities. Hanifa, example of vector quantities, one or two examples. Yes, Hanifa, I'm waiting. Hanifa, you're not audible. Good, Saifullah. Hanifa, can you just write in chat room? Just one or two examples of vectors, nothing else. Your voice is not audible. I can't hear you. I can see that you're trying to speak, but it's not audible. Can you just write in chat room one or two example of vectors? See, for every question, I don't know is an option. Huh? So if you don't know, just write don't know. Good. Velocity, force, electric field, all these are vector quantities. Force is a vector. Velocity is a vector. Electric field is a vector. So all these are the examples of vector quantities. Now, I'm giving you so how we represent a vector? See general representation of vector. See, in general, we represent a vector by putting an arrow over it. So if I take A and I put an arrow over A, that means it's a vector quantity. This is a vector. For example, if I say I have a force of 2 Newton due east, it's a vector quantity. How much is the magnitude of force, Alan? In this example, how much is the magnitude?
Sir, 2.
2. And what about the direction?
Sir, it's towards east.
Towards east. Now, sometimes you need to express magnitude only. So if I ask you to express just the magnitude of vector, So how will you express the magnitude of vector? You will put it in modulus, mod f, and this will be 2 nu. So in general, we can represent magnitude of vector in two ways. We either put that in modulus, or you can simply write A. A without an arrow. It's just the magnitude. So this is general representation. You put an arrow over it, or it's 2 Newton du is, this 2 Newton is the magnitude of force. The next thing is the concept of unit vector. See, in general, a vector can have any direction, it can have any magnitude, it can act in any direction. But when we say unit vector, does anyone know what is a unit vector?
Vector
With
with
magnitude
magnitude
one.
1.
Very good, magnitude. I want this type of discussion in my class. If you know answer, just open your mic and speak up. Don't worry whether it's right or wrong. See, the more you answer my questions, more it will help me to design the lecture. Although it was not my lecture, it was Amna's lecture. I'm just taking the class so that I can know from what level as all faculty should start. So unit vector. Unit vector means these are vectors which have unit magnitude. These vectors can have any direction, but their magnitude will be 1. So this is vectors having unit magnitude and any direction. Unit magnitude and any direction. There is no restriction on the direction. The only restriction here is on the magnitude. Its magnitude should be 1. So it's a different, we use a different notation for unit vectors. The notation that we use here is put a cap over it. This cap will represent that it's a unit vector. So if you have a vector and I ask you to convert this vector in a unit vector, so what you will do, you will take this vector and you'll divide it by its magnitude. So vector divided by its magnitude is a unit vector A cap. That's a unit vector. So if I give you a vector n cap, what is the magnitude of this vector, Mamuna? I just write n cap. I don't write the magnitude. Do you have any idea about the magnitude of this vector, n cap? Mamuna?
It would be like n cap into a n vector will give you n magnitude.
No. It's a unit vector. Cap means it's a unit vector. And what's the magnitude of a unit vector, Mamuna?
1.
1. So if it's n cap, I don't need to specify. It's 1. Okay. So if I write m cap, what is the magnitude of m cap, Mamuna?
1.
1. But what about its direction? It can have any direction, right? When we write
Yes.
n cap, we write m cap. We know the magnitude, but we have no idea about the direction. So for direction, we use some universal unit vectors. Universal unit vectors. So these unit vectors will have fixed directions also. Magnitude was already fixed. Now we are fixing the directions also, x, y, and z. Along x-axis, we are using a unit vector I cap. Along y-axis, we are using a unit vector j cap. Along z-axis, we are using a unit vector k cap. Ellen, what will be the magnitude of I cap, j cap, and k cap?
X, Y, and Z.
Magnitude I'm asking.
Okay, 1.
1. So all our unit vectors, so their magnitudes are 1. Yeah, the direction is along x-axis, y-axis, and z-axis. Aksa, what does minus I cap means? What is the magnitude of minus I cap? Aksa.
1.
Yeah, very good. So minus I cap, the magnitude is 1. What about the direction of minus I cap? Yes, Aksa.
Negative.
Very good. So along x-axis, it's I cap. So when I write minus I cap, it is along negative
Negative
x-axis.
x.
So you can see by putting a negative sign, the magnitude of vector is not changing. Putting a negative sign will just change the direction of vector. So negative sign will not change the magnitude. It will change only the direction of vector. Now, using these universal unit vectors, what we can do is we can express vector into a form which is known as Cartesian form. Cartesian form is inspired from the coordinate geometry. Like if I write that I have the coordinates of point 2, 3, 4. What does this 2, 3, 4 means, Safula?
Coordinates.
Coordinates. X coordinate is 2, Y coordinate is 3, Z coordinate is 4. These are the coordinates of the vector, right? So when I say that vectors are in Cartesian form, that means I'm expressing vectors just like coordinates. Like if I write a vector A, I'm writing this as AX I cap. This is AY j cap. This is AZ k cap. So this simply means along x-axis, the component of vector is AX. Along y-axis, the component of vector is AY. Along z-axis, the component of vector is AZ. Along x-axis AX, y-axis AY, z-axis AZ. So just like these coordinates, we are expressing vectors separately as x-axis, y-axis, and z-axis. If I ask you to calculate the complete magnitude, then the complete magnitude will be AX square plus AY square plus AZ square. This is the complete magnitude. Let's take one example. If I write vector A as I cap plus j cap plus 2k cap, I want magnitude of this vector. Memona, just try how to what will be the magnitude of this vector. This is the formula that we'll be using here.
It will be like root of
Mhm.
a into I square, I cap square.
Not A. What is the coefficient?
Sorry, yeah.
Take coefficient. See here, the coefficient of I cap is AX. Here, the coefficient of I cap is 1. So it will be 1 square. Okay, just tell me the next term.
1 square, yeah.
Next term.
2 square.
Perfect. And how much is it now?
5, root 5.
Root 6, right? 4, 5, 6.
Yeah.
And if I ask you to, so it's not a unit vector. Alan, why this is not a unit vector?
So it's 2 keys, so it's not even matter.
Yeah, its magnitude is root 6. If it is a unit vector, then its magnitude should be 1. Now, I asked you to convert this into a unit vector. Alan, how will you convert this vector into a unit vector?
So divided by root 6.
Very good. So we'll take vector A and we'll divide it by root 6. So your vector A is I cap plus j cap plus 2k cap divided by root 6. So this is your unit vector. Next, addition and subtraction in Cartesian form. Okay, just note it down, then we'll do addition and subtraction. Note down up there. Safula, in the first 10 minutes, you have missed the initial class. No? So in the first 10 minutes, we have discussed the pattern of the paper and the strategy that we'll be following. We can discuss it at the end of the class.
Okay, sir.
Because that strategy part is very important. And the most important thing is believe, like the way when you take admission for class 12th, all of you have this confidence that we will pass the exam in the same way. When you start for the NEET exams, do it with the confidence that you will crack it. If you don't believe in yourself, then you won't be able to do the hard work which is required, because next 7 weeks will be very, very tough for you. The amount of hard work that you must be putting for your board exam, you have to maintain that thing. And trust me, even if out of 720, if you're scoring 600, 610, you will have many, many options in India. Even if you're scoring more than 400, you will have plenty of options. And just like your boards exams, we will, after today's class, we will share the timings of the doubt classes, self-study sessions, and everything. Is there anyone who is new with us who was not enrolled with us in class 12th or 11th? Is anyone who is new at Learnivio? Aksa,
I'm new.
you are new. Sure. So Aksa, you don't. Okay, after the class, I'll brief you like what is self-study sessions and everything.
Okay, sir.
So apart from the regular classes, there are many other things in this course. And you all are aware of those sessions, na? Ellen, Hanifa, Memuna, Saifullah, self-study sessions and all
Yes.
those things. So we'll have similar sessions for the NEET exams also. Take proper notes for the initial lectures. Then maybe after 1 week, we'll share these sheets with you. So you don't have to write everything. But initially note down everything. Once you gain momentum, then we will speed up the things. You must have written up to you, no? And please don't just copy everything, huh? Write in a way that you are memorizing these, you keep on memorizing these relations. Because after the class, you won't have much time for reading theory again. Whatever time you have, you will just solve PYQ, nothing else. If you invest your time in theory, then it will be that you won't be able to do that much of numerical, which is required to crack exam like NEET. The theory required to solve each and every numerical of NEET, that's our responsibility. We'll cover that thoroughly in class lecture. Yes, so everyone have written up to here? Shafula, Alan, Aksha.
Yes, sir.
Yes, sir.
So the next is addition and subtraction of vectors in polar form, Cartesian form. Addition and subtraction of vectors in Cartesian form. So if you have two vectors, let's say you have a vector, it's 2 I cap minus 3j cap plus 4k cap. And you have another vector b, which is I cap plus j cap minus 3k cap. These are two vectors. If I ask you to add them up like vector A plus vector B. So if vectors are in Cartesian form, means if vectors are in the form of I cap, j cap, and k cap, then you don't need any special method for addition. You don't need parallelogram law. You don't need triangle law. You don't need polygon law. What you need is just add them up algebraically. Just add 2 I cap and I cap. That will be 3 I cap. Simply add them up algebraically. So 2 I cap plus I cap is 3 I cap. Minus 3j cap plus j cap, it's minus 2j cap. Four k cap minus 3k cap, it's k cap. So this is vector A plus vector B. If I ask you to subtract A and B, so when you subtract two things, this will become negative. No? This will become negative. This will become positive. Sign will change. So when you subtract them, 2 I cap minus I cap, it's I cap. Minus 3j cap minus j cap, it will be minus 4j cap. 4k cap plus 3k cap plus 7k cap. So when you are adding or subtracting vectors in Cartesian form, you don't need any special law. Just add them up algebraically. Add I cap with I cap, j cap with j cap, and k cap with k cap. Is this clear, everyone?
Yes.
Yes, sir.
Sure, good. Just note it down. We'll do some numericals. Let's solve some numericals from previous year's questions of NEET based on these concepts. Yes, written everyone?
Yes.
Yes, sir.
Okay. So let's do few questions from the UI. Okay, this is the question. Do it. Solve this one and write your answer in chat. See, ideally you have, when you will appear for your NEET exam, you will have 1 minute or 1.5 minutes for a question. But since we have started the course, you can take 2 minutes. Try to do this in 2 minutes. Even if you take 3 minutes, it's okay. But
So
try,
should we write the questions?
or don't write the question. I will share this book with you. I'll be sharing this whole book with you, the soft copy of the book. Just write down the question number. That's it. Just note down the question number. Rest will be in the book. Okay, very good, Ellen. So I got one answer from Ellen. What was the rest? Answers? Okay. I got one answer from Ellen. Hanifa. I'm expecting answer from each one of you. Even if you are calculating and your answer does not match with the result, you can even write, I don't know, or my answer doesn't match with it, but I need response of each one of you. Okay, Aksa. So Ellen, Hanifa, Aksa, Saifullah, and Mamuna. Okay, I got answer from Mamuna also. Ellen. Saifullah, are you solving it?
Yes, sir.
Okay, I'm waiting. Do and write your answer in chat. Let me start. So you have a vector which is 0.5 I cap plus 0.8 j cap plus ck cap. You have to calculate the magnitude, which is root over coefficient of I cap ka square. So it's Saifullah is solving it in this way only.
Yes,
Plus
sir.
0.8 square plus c square. So Saifullah, what should be the magnitude?
1.
1, because it's saying is a unit vector. It's 1. So when you see what next, what you can do is you can take square on both the sides. When you take square on both the sides, it's 0.25 is 0.64 plus c square is equal to 1. So you can write that c square is 1 minus 0.64 and 0.25, 0.89. So when you subtract it, it comes out to be 0.11. So your c is 0.11. Okay, Saifullah, clear?
Yes, sir.
So Ellen was making some mistakes in subtraction, I believe. Ellen, you made mistake in this subtraction.
Yes, sir.
Okay, rest Hanifa, Aksa, and Memuna were correct. So note it down if anyone want to write it. See, NEET is easy. Like, and usually in NEET, they don't combine various topics in questions, especially in physics. While in JEE, they combine 2-3 concepts while making a single question. NEET asks many questions which are on a single concept, which are easy to handle. If you know a concept, then easy to handle a question which is involving a single concept. But when you come to exams like JEE, they involve many topics in one concept. Okay, let's start with the next thing. So this is the addition and subtraction of vectors when they are given in a Cartesian form, means when they are given in I cap, j cap, and k cap form. But how will you add them up if vectors are given in polar form? So polar form means Along with I cap, J cap, and K cap, you will be having the angle between the vectors. Angle will also be given. Okay, so there are two forms. One is Cartesian form, another is polar form. In Cartesian form, you have I cap, J cap, and K cap. Unit vectors are given. In polar form, you have vectors and the angle between them. Angle is given. That means the vectors are in polar form. So if vectors are given in polar form, then you can use these three, any one of these three methods. First is parallelogram. Second is triangle law. Third is polygon. So parallelogram. So to use parallelogram law, conditions to use parallelogram law. So you will use parallelogram law if first condition is if you have two vectors, like parallelogram law can deal with two vectors at a time. It deals with only two vectors at a time. Means if you have five vectors, then you can't add five vectors simultaneously using parallelogram law. What you can do is you will add two vectors, and with the result of two, you will add third vector. With the result of that, you will add another vector, and this is how you will proceed. You can't add three vectors simultaneously using parallelogram. Second, vector should be coinitial. Vector should be coinitial. When we say coinitial, coinitial means they should have same starting point. If starting point of two vectors is same, this is the starting point, and this is same for two vectors, then we call them as coinitial. So coinitial vectors have same starting point. So let's start with the parallelogram law now. So the condition is it will deal with two vectors at a time, and the vectors that you're adding using parallelogram law should be coinitial. To use parallelogram law, let's start with this thing. So you have two vectors. This is a vector A, and this is the vector B. They're placed at an angle theta. So you're supposed to calculate a resultant vector R, which is the sum of vector A and vector B. This is what you have to calculate. So to calculate the resultant vector R, the first thing is see, this addition is not a normal addition. This is a vector addition. To do this vectors addition, there are three steps which are required. Step one. We call step one as geometrical construction. In geometrical construction, what you will do, you will complete the parallelogram. You will take a line which is parallel to vector B, and you will take a line which is parallel to vector A. And this diagonal of the parallelogram, this diagonal here, will represent the vector R. This is the resultant vector R, which is vector A plus vector B, vector sum. So to add two vectors using parallelogram law, or when you do vector sum, there are usually three steps which are involved. First step is geometrical construction. So you complete the parallelogram by taking sides parallel to the vectors. The diagonal of the parallelogram will represent the resultant vector. When I say resultant vector, it means the sum of vector A and vector B. That's the first step. The second step that is involved here is calculation of magnitude. So if you want to calculate the magnitude of vector R, that's A square plus B square plus twice of AB cos theta. This is how we calculate the magnitude of resultant vector R. And the last step is the calculation of direction. You can calculate direction also. So for direction, what we do is, this is vector A and this is the angle beta. So direction means we have to calculate this beta. So to calculate this beta, what we do, we calculate tan beta. What is tan beta? Tan beta is B sine theta divided by A plus B cos theta. So this is how we calculate direction. Tan beta is B sine theta by A plus B cos theta. Beta is the angle. If you know angle, you know direction of vector R. So this is how we add two vectors using a parallelogram. Is it clear, everyone?
Yes.
Yes, sir.
Okay, note it down. Then do a formula-based question over it, and then we'll see how this question can come in your NEET exam. We'll do some question from the PYQs. Note it down. So Hanifa, what does this thing polar form means?
The vectors with an angle.
Yeah, if angle is given, that means vectors are in polar form. And Aksa, what does Cartesian form means?
Vectors on a Cartesian plane.
No, Cartesian form we did just now. What does Cartesian form means? I cap, J cap, K cap, right?
Yes.
You should keep this thing in mind. Both the forms have different laws for addition and subtraction. Can I scroll it down? Alan, have you written up to here? Can I scroll it down?
So
Yeah, I'm giving you a formula-based question. Just try to solve it up. So you have two forces. Force F1 is 1 Newton. This is 2 Newton. Angle between them is 60 degree. Calculate net force. Do it. So you have two forces, 1 Newton and 2 Newton. The angle between them is 60 degree. Just add them up. This is a formula-based thing. Just solve and write your answer in chat room. I need both magnitude as well as direction. Answers. This is a small calculation. Cephala, how to solve? Okay. Cephala got the right answer for magnitude. Yes, very good, Cephala. Your magnitude is correct. Correct. Now just try to get the value of direction also. What about the rest, Mamuna, Hanifa? Aksa, any issue in the calculations?
Okay.
Okay. No, Hanifa, just check your calculations once more. Aksa is correct. Alan is correct. Hanifa, you are doing something wrong. See, it's 1 Newton and 2 Newton. No, Mamuna. Mamuna, you can't add them up directly. See, you just can't do 1 plus 2 equal to 3. You have to apply the entire parallelogram law. See, no one calculated the direction. Aksa, Hanifa is wrong, Ellen is correct, Mamuna is wrong. Okay, Saifullah sent the direction also. See, for magnitude, Hanifa, just tell me the formula to calculate magnitude. Hanifa, formula for calculating magnitude. The formula, yeah.
Root A square plus A1 square plus.
So instead of A, I will write F1, then F2 square, then 2F1, F2 cos 60. So your force F is its root over F1 is 1 square. F2 is 2 square. 2F1 1 into 2 cos 60 is 4, 5, 6, 7, root 7 meters. Now to calculate direction, you first have to complete the parallelogram. Then let's call this as beta. So the tan beta will be, tan beta is b sine theta by a plus b cos theta. This is the formula. Now you have to decide out of F1 and F2, which one is A and which one is B. So the vector with respect to which we define your beta is A. So this is your A and this is your B. So you can write this as B is 2 sine 60 divided by A plus B cos theta. A is 1 plus B is 2 cos 60. So this is 2. So how much is sine 60? Sine 60 is root 3 by 2. Divided by 1 plus 2, how much is cos 60? Cos 60 is half, so gets cancelled out. So that's root 3, 1 plus 1 is 2, root 3 by 2. So you can write that your beta is tan inverse root 3 by 2. So I'm repeating again, how will you decide which one is A and which one is B? The vector with respect to which you have defined your beta is A. So I have defined beta with respect to F1, so my F1 is A and F2 is B. If I define my beta in this way, then which one is vector A, Hanifa? If I define beta with F2, then which one is A and which one is B?
F2 is A.
Yeah, and F1
F1
is B. Good. So the choice of A and B will depends upon the choice of beta. Okay, note it down. We'll do some special cases of it. Okay. Now we have few special cases also. Case 1. If vectors are parallel. So if you have two vectors and those two vectors are parallel, that means the angle between the vectors is 0 degree. You want to calculate resultant vector R, which is sum of vector A plus vector B. The magnitude of resultant R is root over A square plus B square plus 2AB cos 0. Or no need to derive it. You can just write them directly. So if vectors are parallel, then no need to apply the parallelogram law. Whether you apply parallelogram law or you add them up directly, they're the same thing. So if two vectors are given which are acting in same direction, then no need to use the entire parallelogram law. You can add them up directly. Like if this is vector A and this is vector B, they're acting in same directions. No need of parallelogram law. Just add them up directly. Even if you apply parallelogram law, A square, B square to AB cos theta, you will get the same result. The direction of resultant is same as that of vector A and vector. Case 2. So here you can write that vector A plus vector B is equal to mod of vector A plus mod of vector B. So this is true only if vector are parallel. Otherwise, in general, it's not true. Vector A plus vector B is A square B square 2AB cos theta. You can add them up algebraically only if they are parallel. Similarly, case 2. If vectors are anti-parallel. What does anti-parallel means, Aksha?
In opposite direction.
Yeah. If I say that vectors are anti-parallel, that means angle between them is 180 degree. And yes, they're acting in opposite directions. This is vector A and this is vector B. So when you calculate resultant, it comes out to be root over A square plus B square. It's plus twice of AB cos 180. So when you do all these things, it comes out to be A minus B. Which means if two vectors are acting in opposite directions, then again, you don't need parallelogram law. Just subtract them. See, we are adding two vectors. Vectorically, we are adding, but algebraically, they get subtracted. Or you can write this thing as vector A plus vector B, means if you're adding two vectors vectorically and they are anti-parallel, then this is magnitude of vector A minus magnitude of. And this is true only if vectors are anti-parallel. Case 3. If vectors are perpendicular, A is perpendicular. That is an easy thing, like resultant, the magnitude of resultant is just A square plus B square. You don't have to do the entire AB cos theta thing. And tan beta, if you want to calculate, if this is vector A, this is vector B, this is your resultant. I want to calculate this beta, then tan beta is B by A. These are the special cases. So if you get questions from any of these special cases, then calculations get reduced significantly. Because parallelogram law is a lengthy thing. You A square, B square, 2AB cos theta, then direction. But if you have any of these special cases, then the calculations are very straightforward. Just note it down. We'll discuss subtraction of vectors also, and then we will start doing numericals over it. We'll get many numericals from parallelogram. Jasola, any doubt in it?
No, sir.
Alan?
No, sir.
Okay, from tomorrow onwards, can you do one thing? I will be using the focus mode. So please sit in a way that you can just switch on your videos. So if you switch on videos, your concentration level will boost up.
So for second case, when they are anti-parallel, what is the direction of the resultant vector?
Yeah, the resultant will act in the direction of greater vector. So the vector whose magnitude is greater would be the direction of resultant. So if A is greater than B, then R will act in the direction of A. If B is greater than A, then R will act in the direction.
Okay.
See, when we use focus mode, then only the host, your faculty can watch you, not no one else can see you, and your video will not even come in the recording. See, when you go to school, then also you people can see you now. You are in front of them. Same thing here. I'm planning to make it compulsory even in 11th and 12th this year on. Because once you switch on your videos, there won't be a difference between offline classes and online classes. Online have distractions just because we can't see you. The best thing is when you sit for classes tomorrow or the next day, just sit in a way that your camera is facing towards the wall. That's the best. Yes, can I scroll it further? Okay, the next is subtraction of vectors. Because the questions that you will get will involve both addition and subtraction. See, subtraction of vector is similar to addition of vector with just a very, very small modification. Let's say this is vector A and this is vector B, and these two vectors are inclined at an angle theta. You're supposed to calculate vector R, which is vector A minus vector B. You just have to subtract them. So to subtract them, you can write this in this way, that you are adding vector A negative of vector B. You're adding minus of vector B to vector A. Mamuna, what does minus B means? This is B. Where is minus B? Anisha?
In the A direction.
No, in a direction opposite to that of B. Huh? This is minus. Minus B means the direction opposite to that of. Now you have to add A and minus B. So let's complete parallelogram here. This is the resultant. This resultant will represent A minus B. If you want to calculate the magnitude, it's simply A square plus B square minus 2AB cos theta. And what was, say, you want direction also? This is beta. What was the formula for direction? Alan, tan beta. What was the formula for direction?
B sin theta by A by B cos theta.
B sin theta by A plus B. So instead of A plus B, this will be A minus B cos theta. So this is the small difference. B sin theta by A minus B cos theta. Note it down. We'll start numerical. So just instead of this plus 2AB cos theta, you have minus 2AB cos theta in subtraction. And instead of A plus B cos theta, you have A minus. Yeah, can I scroll it now?
Yes, sir.
Okay, let's do some questions. Okay, just do this question. Question number 1. No, sir. Just check your calculations also. It's not a correct answer. Sum of two vectors means vector addition. Difference of two vectors here means vector subtraction. Difference of two vectors is vector subtraction. No, Alan. Okay, I'm giving you people agree. Very good, Memuna. Memuna is correct. See what you will do. You will take formula for vector addition, which is a square plus b square plus 2ab cos theta. And then you will take formula of vector subtraction, which is a square plus b square minus 2ab cos theta. Just equate them and get the value. Do it. Just equate them and get the value. Safula. Hanifa. Good, Safula, that's correct. Good, Ellen. Right. Okay, I'm solving it now. So you just have to. Good, Hanifa, it's correct. Equate addition of vector, which is a square plus b square plus 2ab cos theta, which is equal to root over a square plus b square minus of 2ab cos. So when you equate them, this root will cancel the root. You will be left with a square plus b square plus 2ab cos. And this will be a square plus b square minus 2ab cos. So this a square will cancel this a square, b square will cancel this b square, 2ab cos theta plus 2ab cos theta will be 4ab cos theta, which is equal to 0. So this is true when cos theta is 0, and cos theta is 0 if theta is 90. So 90 degrees. Is it clear, everyone? Aksha?
Yes, sir.
Sir, I did with the direction, like tan beta formula. Is it-
But Alan, here the formula of tan beta will not help because whatever data is given is only about the magnitude. So if you are using this relation, like if you are using tan beta is b sine theta over a plus b cos theta, right? So even in this relation, the beta is not given. It's not given the value of beta. The thing which is given is magnitude. You can compare the magnitude of two cases. That's why I'm saying this won't help in this middle.
Okay.
Okay, let's do one more numerical. That's a bit lengthy, a lengthy calculation. Okay, one similar question from Jay. Just try to solve it. Do it. Okay, is options is also given. Similar question. Just very, very small modification. The approach will be same as that of previous question. But just the calculations will be lengthy. Are you able to solve it, or you want me to solve this question? See, the approach is same. Aksha, you solving it?
Yes, sir.
See, just the calculations are lengthy. I believe the calculations will take 10-15 steps something. Just have to calculate cos theta, nothing else. Just like previous question, you need cos theta. Answers. Okay. Ellen got some answer. Seems correct. Okay, let's solve it together. Huh? The magnitude of a plus b is n times the magnitude of a minus b. So the magnitude of a plus b is this, a square plus b square plus 2ab cos theta, which is root over a square plus b square minus 2ab cos theta. And they are not equal. This is n times this. Huh? Now take square on both the sides. You will get a square plus b square plus 2ab. Does anyone else got any answer? Else than Alan? Aksa, Hanifa, Saifullah. Okay, Saifullah got something. Seems correct. Next, you need this cos theta. Na? Take cos theta terms to the left hand side. So you'll be left with 2ab cos theta. And this is n.
So shouldn't be n square.
Yeah, right. Thank you. Should be n square. Plus n square 2ab cos theta. You can take terms to the right hand side. So this is equal to n square a square plus it's n square b square minus a square minus b square. Next, what you can do is you can just take 2ab cos theta as common. And you have 1 plus n square here. Similarly here and here, you can take a square as common. And you have n square minus 1 plus b square as common. And you have n square minus 1. So this is 2ab cos theta 1 plus n square. Now you can take n square minus 1 as common. There is one b left out. And this will be a square plus b square. So your cos theta will be it's n square minus 1 a square plus b square divided by 2ab 1 plus n square. Is there any term which is missing? A square plus b square is n times a square plus b square minus 2ab. So it's na square b square minus 2ab cos theta n square. So cos theta plus n square 2ab cos theta, which is n square a square plus n square b square minus n square n square. Cos theta plus n square is a square. And what are the options? N square minus 1 n square plus.
So I can take b square as a square, so it get cancelled out, right?
Which one?
You can take b square as a square, so it becomes 2a square. And down there, I can take b as a, so it can become 2a square, and you cancel them.
I didn't get you, but you're saying, can you just repeat?
Yes, I can take b square as a square, so it
B-
becomes 2, yeah.
B square plus a square.
Yeah, so it becomes 2a square. Because
B-
a square equals b square, right, over here.
Okay, they have equal magnitude. Fine, fine.
Yeah, so
We
they
can-
get cancelled.
Okay, okay. Yes, 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 they are equal. Perfect. So A is equal to B, now it's given. So you can write this as cos theta is n square minus 1. So it will be, instead of B, I'm writing A, it's a square plus a square. Similarly, it's twice of a square. And then 1 plus n square. So this whole will cancel this term. So cos theta is n square minus 1 by n square. Yes. So C is the correct option. Just note it down. Is it clear, Mamuna?
Yes, sir.
Sure. Note it down. Yes, so everyone have written up to here?
Yes.
Okay, now please note down your homework. So today I won't give you question from NEET PYQ. Today you will practice some questions from JEE PYQ. These are lengthy questions, but at least you will get used to of calculations. So I'm asking someone to share this book with you. Just note down the page number and question number. So motion in a plane, this page number is 27. Question 1. All questions are either based on unit vectors or they are based on parallelogram law. Question number 3. Question 6. This is already done. Okay, that's it. So from vectors, you have to solve only these questions. These are lengthy questions. They will need some time, but the calculations that you will learn in these questions will helps you in other chapters also. Like you will use this calculation in electrostat and magnetics also. So, okay, so let's stop here. We'll continue this in the next class. Stop here. So from 5 o'clock, you have your chemistry class. Is your chemistry class in the schedule? Na?
Yes.
Yes, sir.
Yes.
Okay, so